Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about extraction of caffeine from coffee and tea. So in this video, I will discuss about the introductions, then extractions theory, then basic process of extractions, then the difference between extraction and washing, and then I will discuss about identifying the aqueous phase and organic phase, then how much solvent, how many extractions, then how you will write in your notebook, aim of the experiments, materials required, then what is the procedures, then extractions, step by step, then finally I will show you the calculations, then microscopic examinations and references. So let us start with the introductions. My friends, caffeine is a natural product found in the fruit and bark of certain plants. It is well known that caffeine is a stimulant, a diuretic, and is additive. The stimulant's action is why a lot of us drink so much tea, coffee, and certain soft drinks. But it is also used in some medications to reverse drowsiness. Caffeine has been described as the most abused drug in the US. A single serving of coffee may contain 125 milligram tea, 75 milligram coca, 40 milligrams Coca-Cola, 46 milligram. A regular 4 cups a day coffee drinker or withdrawal can experience headache, insomnia, even nausea. It is a brief introduction about caffeine. Our aim is the extractions. So what is the extraction theory? You know, my friends, solvent extraction is a process of purification involving the use of two solvents or solutions that are immiscible with one another. The main use is to employ extraction as a means of isolating chemicals that are present in plants or animal tissue. You can see in this picture, this is one glassware, and this glassware name is separatory funnel. Here you can see here a stopcock. The main use is to employ extraction as means of isolating chemicals that are present in plants or animal tissue. Now, it is extensively used in organic chemistry as a way purifying reaction mixture after a laboratory experiments. It is based on the different solubility of compounds in water and an immiscible organic solvent, typically diethyl ether, chloroform, dichloromethane, ethyl acetate, and this allow the desired. Now friends, you know, organic compounds to be separated from inorganic or very other polar byproducts. This is the basis of an older industrial method for decaffeinating coffee. You know, a conical shaped piece of glass called the separating funnel, I already show you, is the laboratory tools used for most types of extraction. Be careful when using them, they are not cheap. The general process involved adding the two immiscible solution to the separatory and shaking with occasional opening of the stopcock. You can see. Now, the basic process of extraction. First, make sure the stopcock is secured and closed. This is stopcock of separating funnel. Place a collection flask underneath the funnel here. Use an iron ring to support the separating funnel so it is not fall down. This is the iron ring. Two heterogeneous liquid solutions are added to the separating funnel. Here you can see there are two. The mixture of solutions is shaken with occasional venting to relieve any pressure buildup. Venting, just remove the stopcock here. Now the lower layer is drawn off through the stopcock. This is the lower and this is the upper layer. Lower layer you can take it out by opening this stopcock. Now the difference between extraction and washing. Extraction is the removal of desired compound from one phase, usually the aqueous phase, into another, usually organic phase. Washing involves the removal of impurities by shaking the solution with a aqueous solvent, and that will dissolve only the impurities and leave the desired compound behind in the organic phase. And this is the difference. Now, furthermore, identifying the aqueous phase and organic phase. Keeping track of which layer is the organic layer and which is the aqueous layer can be frustrating. First, you have to clear which one is which. However, if you remember one simple rule, then your trouble will be few. The rule there is that the more dense liquid will be on the bottom. If you are in doubt, there are two things you should do. First, remove a drop of one layer and place it in a small test tube. Add a drop of water. If it dissolves, the layer is aqueous. If it does not, then layer is organic. Write it down here. Remove a drop of one layer and place it in a small test tube. Add a drop of water. If it dissolves, the layer is aqueous. If it doesn't, then layer is organic. Now, second, save all of your discarded layer until the end of experiments. Now, my friend, how much solvent, how many extraction? That is the question. The general rule is to perform multiple extraction with a smaller amount of extracting solvent rather than one extraction with a large amount of solvent. Remember, we are dealing with the partitioning of a solute equally between two phases. By performing the extraction a number of times, we can effectively pull out more material than if doing it once with a large amount. Now, how you will write in your lab notebook? You have to write aim of the experiments. What is the aim? In this experiment, you will extract caffeine from tea leaves with dichloromethane. Caffeine is about 9 times more soluble in dichloromethane than in water. This concept is very important if you are interested. Using separating funnel, be careful not to shake too vigorously or you will get an emulsion that is difficult to separate. So you will also learn how to dry an organic solution, removing trace quantities of water using chemical drying agent. So this material you required for these experiments. These materials are 1 tea coffee dichloromethane, commonly known as DCM, 6 sodium hydroxide, anhydrous magnesium sulfate, deionized water, DW, and ice. Wear gloves when handling DCM dichloromethane. It also has harmful vapor. Avoid skin contact and avoid breathing the vapor. Keep in the fume hood whenever possible. Then you have to follow the procedure like weigh tea from 20 tea bags, 3 spoons Arabic coffee, 100 ml boiling deionized water or distilled water, stir for 7 minutes, filter by filter paper, cool the filtrate in an ice bath. Then do the extractions. Pour the cold tea filtrate into a separating funnel. Slowly add 20 milliliter DCM and gently stir to layer for 5 minutes. And then replace the separating funnel into the stand. Remove the stopper and allow separating for about 5 minutes. Then collect the organic phase into conical flask. Don't allow any of darker material to escape through the stopper. Repeat the extraction twice more with fresh 20 milliliter of DCM. Add these 2 DCM layer to the first. If an emulsion remains in the DCM, filter through a Buchner funnel. Then return the organic phase to the SF here is separating funnel and stacked with 20 milliliter 6 sodium hydroxide twice and once with that 200 milliliter deionized water. Then collect the DCM layer into a conical flask. Then dry the solution by adding 1 teaspoon full of anhydrous magnesium sulfate and then allow standing 5 minutes. Filter and then weigh empty flask. Then transfer the filtrate into flask and evaporate DCM on the water bath. Then finally weigh the flask containing the crude products. As usual, you have to do the calculations. Determine the weight of pure caffeine in each of your sample and calculate the percentage weight of caffeine. The weight of caffeine weight of the sample. Then do the microscopic examinations. You have caffeine, add few drops of mercury chloride HCl to examine under microscope needle shapes. And this is the references, figures and others. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.